Hello everyone. Myself Niladri Biswas, research scholar from IIT Mandi. So I'm discussing about some about important problem of the flow that is for the subject of applied computational fluid dynamics ME 615. First we have a list, that is a list of contents. So on the contents we have some problem statement, then we have the particular model description, and then go for the geometry and mesh, then solver, then the result and discussion. So first, as per the problem, as stated in the problem, that we have to solve the external flow problem of a flow past a 2D body using OpenFoam open source software, and the shape of the body will be the elliptical, where the major axis along the streamwise major axis is in the streamwise direction. So this will be the domain. So we can clearly see the domain. The domain we are taking as a 15 by 15 by 10 domain, a rectangular domain, and in the domain, and the initial part, the internal part, we are in the that initial part we have our that cavity, that is that shape of the cavity is kind of elliptical, and also we have no slip condition of the body of that cavity, and in the inlet portion we can see the V inlet equals to 0 and U inlet equals to 1. So that is the initial condition for this, and we have the no slip condition in the top and the bottom, and this will be the pressure conditions for that particular problem. So after that, for the doing this one, we have to use the governing differential equation. These are the governing differential equation. First one is the continuity equation. Second one is the moment equation, the for the x direction and the y direction. And also we have the boundary condition that already I mentioned before. So this will be my boundary condition. After that, we have to go for the geometry and mesh. This will be for this one we have to use the Gmesh software, and after that we have the solver, that is the OpenFoam solver. That is a very useful solver actually, and with that we have to use some kind of isoform particular problems, and after that we are going for some result and discussion, grid independence analysis, and the choice of final method, and so on. Let's start with the first the geometry of that diagram. So just let's open open form first software. Then we are only creating a folder that is named as dummy. So let's just double click on that. I'm double clicking this thing. Under that we have created one more file, that is open form 1. Let's double click on it. Under that we have two files, that is one is cavity, one is geometry. Just double click on geometry. We have to create the whatever the geometry and meshing part we have to do. So just right click on it, and let's open the open terminal. Let's click on the open terminal. Let it come. So after you can just write ls enter. So the terminal has been opened right now. Then we have to type gmesh to open the gmesh. So let's enter this thing. Now first we have to we have to take the points for the domain and the cavity. So just click on the geometry, then elementary entities, then the add, and that we have to take the point. So just take the point first. So first starting with the originating point, that is 000. So we have to type x. Before that we can just freeze that three thing. That will be easier to handle right now. So let's type 000 for the first time. Okay, so just add this on the first point, then going for the next point, that is 15 and 0 and 0, that is the second point, and the next point should be 15, 10, and and just click on add. And the last but not least, we have to select the 0, 10, and 0. So just we have to add this thing now. Okay, just add this one. So we have the 4 points for which that we can create the domain. So next, going for the cavity portion. So let's draw first indicate the midpoint of the geometrical center of that particular ellipse. So that is become 2 5 and 2 5 and 0. So that is become your 2 5 and the 0. So we can take that mesh prescribed point as 0.1. So that is we have to first we have to add this one. Then going for the next one, we have to go for the major axis and the minor axis. And so we have to take 2.5. Oh, sorry, 2.5, 5.5, and okay. So this will be the next point. The next point is 2.5 and the 4.5. So that is the we have to add the second point. Similarly, the third point should be 1.5 and 4.5. And then last but not the least, the next point should be 4 1.5 and 5.5. Okay, so after taking this one, we have to join this point by helping with the that lines. Okay, we miss one point, that is we have to select this point also, that 0 10 point we missed out. So just double click on the point and just take the point as 0, that is 0. This one is your 10, this was is your 1. Okay, so just add that point over it. Okay, so now all points are taking, that is done. Okay, next we have to select the line. Selecting the line, then we have to join together 2 points at a time. So just like first point and second point and the third point, third point and the fourth point and the first point. Okay, it's not selected. Let's select the first point. Okay, so it's done. Then just press Q to about the function, and then again select the line. Not the line. Actually, we have to create the uh, that thing. Okay, so we have clear. We are taking the wrong line. We have to take the lines here. Like we have to do some changes over there. So we are taking some wrong line. Actually, for the square, so we have to take some other lines. So you can just click on the edit script, let it open. Let's do some changes for the ellipse actually. So the major axis should be like 250, that is the midpoint. Then the the fifth one should be the fifth one should be 2 point, that should be 3, that is 3 and 3 5 and 0.1. Just we have to change this one. We have taking for the another kind of structure, so we can change this one. So just change it, that is 3, that is 1. Okay, so this is your 5. Then 2 and 5.5 and 2 2 and 4.5. 4.5. This study have to do the second bracket. Okay, just save it. Just save it first. Save it and just close it. So we have some points for the thing. So just thing reload this thing. Okay, now we have to select the ellipse arc. So ellipse arc, by selecting the ellipse arc, we have to select the all the ellipse part of the ellipse, four part. So first, this one, first point, center point, and the that major axis and that is the end. So this will be the first one. Then again similarly we have to do the other thing, the ends, first point, center point. Okay, there are some mistakes, so just remove last script. Again do the same thing. Those the first center to center, then the major axis and the end. So this will be the same end. You can select the same end like this. Just zoom it in. Okay, similarly for the next part also, the first point, midpoint, that center point, the major axis and the last point. Okay, again I'm doing the same thing. Okay, so again the first part, we are starting from this point, first point, midpoint, the major axis point, and the end point. End point should be this one. Similarly for the last part, we have to select the first point again and again the first point. This will be the first point. This is the selected yet. First point, midpoint, or the center point, then the major axis, and this will be the end point. So by this we can create that particular that cavity. Then the next part, we have to select the plane surface and then select the boundary. So this will be the first boundary, the outer boundary, and this will be the cavity boundary, that is the inner boundary. So that will create some cavity. Then just press E, so it can create some particular that particular plane surfaces through it. Just click E over it. So as we see that by selecting the plane surface, we have selected the plane surface. Now let's go for the extrude. So let's extrude, and then the translate. Go for the translate. Then select the extrude as one. Select the extrude as one. The one, and select that surface to extrude. Then so press E. The surface has been created. So we can see the surface by just rotating this one. So you can see that there is a 3D, right? The 3D the system right now. Fine. So next we have to go for the physical groups. Physical groups, because we have to name the surfaces of physical group, and then we are first selecting the surfaces. Surfaces. After selecting the surface, we have to name the surface. Let's select the first surface as inlet. So we just put the name as in or inlet, whatever it's, you can put that is in. So I put in the in. Just select the inlet surface. This will be the inlet surface, and after selecting this one, just press E. Just press E. Similarly, for the next we have to go for the next one, that is your outlet. So just you can put the out and selecting the outer surface. This one is the outer surface. Click on it and just press E. Similarly, the next one, just press the just go for the top boundary. So just press stop. Just press stop. Just press stop and okay. So we can just take some rotation of this thing. Okay, so we have to select that top one. The top one, just E, and again the bottom one, that is we can select the bottom one and select bottom one. Select that uh, lower portion or the bottom portion. Selecting this one, then E. Also, we have to select the ellipse. So ellipse should be like so ellipse. Ellipse, you have to select the ellipse for you have to select all these four boundaries for this 1, 2, 3, and 4. After selecting the four boundary, you have to choose the E again, and the last but not the least, you have to select the front of the frontal and backward uh, sides. So just you can put, but we can take it together. So just we can write F and B for the front and back, and just select these two surfaces or two faces simultaneously. So just press E. So that is become your the surface selection part is done. So after the surface selection part, we have to go for the volume. We have to select the volume also. So double click on the volume, and after that you have to after double click on the volume, you can give the name as like like flow flow. Then select the select the that midpoint or that is creating that selecting the volume of this thing, and just select E, and after that just that has been selected, and you can cut this one, and then you can go for the meshing. For the meshing purpose, you just click on the mesh. You can click on the mesh, and then you have to choose the 1D, then the 2D, and after that following through the 3D. So as we see, we have some meshing property right now. Now we have to export our file to the OpenFoam. So just click on the flat file. Okay. Next, we have to select the export. After selecting the export, then we have to locate the file. So just locate this one. Okay. So first we have to select the extension. As first that is the msh meshing mesh. So then we have to select that dummy OpenFoam and the geometry. Under the geometry, we have to select any name. That is, I can say that uh, ellipse.mesh. So let's click on OK. Okay, so also you have to select this one, version 2. Sorry, that is version 2 AC double 2, and then select OK. Okay. So now after that we have to go for the we have to select the file. Means we will have to open the file, and we have to move the particular some files, means particular some files to the folders. So let's select that first that ellipse that we have just created. So just copy it and just move it to the OpenFoam one. OpenFoam one. Okay. So select the cavity It's taking some time. Okay, fine. Uh, just select the paste here. Okay, fine. Then open the open the terminal through that particular location. So after opening that particular terminal, we have to do some. So I just open. Okay, fine. Then we have to do some particular give some particular input. So after opening the thing, we have to put some that particular input. So yeah, so that is we have to. इतना काफी है ये तो इतना जितना है जब रुक जाएगा खत्म वो तुम निकाल रहे हो खत्म उसको करना ही नहीं मेरे को मेरा हो गया मेरा आपका कोड when we use the input we can get that file so to choose the DNS to the ellipse so we can get this up to this. So as you see by from the terminal after the we have already created that part is created that constant and through it we can find a boundary condition of the boundary file. This the boundary file is should looking like okay so double click on it. So the boundary file is coming like this only. So in the boundary file you have to change something like in the front back side in the type portion you have to select the empty, then the top portion you have to in the top part you have to select the wall and to the delete the patch portion, and again also in the bottom portion as well as you have to select the wall and you have to remove the that physical type patch thing, and also in the each part you have to choose the type as well, and then you have to just save the file and just one okay just save the file and just cut it down. Okay, so just we have to we have a new value over that physical properties and we have to just copy that one. We have to just copy that file into that constant folder and just copy that one over that, then go for the cavity. Okay, so we have one file on the zero file, that is the p, that is pressure coefficient. So now we have to open the boundary and p togetherly, and then we have to copy. So we have to copy from that form rec section. So we have to copy the front back section to the and after that, okay. So we have to copy from the boundary and we have to paste it over the paste it over the P folder to paste the thing over that P uh, after the that commands. Then in the front and back we have to just make it empty. So just make it empty right now. Okay, now we have to select that type zero gradient. We have to type the type zero gradient. We have to just copy this one and we have to just change the whole thing. Just copy. Okay, so this is the top. We have to select this one and okay, sorry. So just we have to select that part and just change this thing. Again, the bottom part also become the zero gradient one. So just even in the ellipse part, we have to do the same thing again and again. So just select this one and just control V, so that it has become the thing. As in the inlet section, as in the that inlet section that is satisfied the dead set conditions. So we have to put it, the type should be like 0. So we have to select the basically that is become 0. So we have to put the 0 get it, just copy it and just put it over there. So okay, like this only. So in the outlet portion, that is also satisfied the delicious condition. So this should be the fixed value over there. So that is the, if I explain fixed value. Okay, so value and the values become uniform 0. Now save the folder and open the open that U folder as well. Next we have to copy the lower part from P to the U. We have to take top as no sleep, no yes, no sleep, and also the bottom should be the same, that is no sleep. Bottom should be the same, that is no sleep, no sleep. Also the ellipse part should be the same, that is the no sleep. For the inlet, in the type we have to take the fixed value. We have to take the fixed value xcd fixed, yes, fixed values. And the value should be uniform as 1 0 0 1 0 0. Let's take a bracket, and also close the bracket and semicolon. Okay. Also the outlet should be the 0 gradient. You can copy this one. Okay, so we can copy this one from this. Just copy this one. Just copy that thing, and we have to put it over outlet, and put it over outlet. Okay, so we have to put it like here also. Let's change the V. Okay, let's move left. Okay, so we have to delete the previous folder after do the editing for the P and as well as the U. Both you have to just delete the previous files so that we can go for the updated one. Now in the system folder we have a part that is contour depth. So we have to select this one. We have to go for the 10 steps. So we have to just select this one and take 0.5, and the next one is we can take 0.005. Sorry, we have to take it as 0.005, and this one we can take as 20. This one is a 0. Okay, so it's okay. So just save it first. Fine. Okay, so we have to go for the terminal, and we have to write check mesh. CG C. Okay. So just we have to click OK. So you have to just click OK. So it's just showing that our machine is okay or not. So by keep the checking command, so we can say by clicking on the check mesh command, that is showing that that's our mesh is okay. So just put the command as IIFOAM and just click on enter. So let's see what's coming out. Next, after that we can go for the fade. So next you have to go select the perform. So you have to select the perform and then select the enter. So to select the so type the paraform and then enter. After that, after opening this one, after the paraform opening, you have to choose the apply. You have to choose the apply over there.